जेरोस इसलिए है कि उनको दोबारा करना पड़े।
वाला सेटिंग सारा खुद उसमें यूट्यूब किया है, मैं खींच के बता देता हूँ कि हमने सर ये वाला किया है, यही वाला करना था ना छोटू। सेटिंग्स को
स्टोर करना पड़ेगा।
क्यों ऐसे ही खुल जाएगा? नहीं खुलता, खुल गया ना। इसको क्लिक कर जा रहा है यहाँ पे, क्या क्या ऑप्शन?
ये डायरेक्ट ना
लाइव हो स्टार्ट।
लाइव वो क्या बोले लाइव हो।
सर आ रही है ना वॉइस? चालू हो गया? हाँ अच्छा, लाइव चालू। ठीक।
गुड इवनिंग एवरीवन। Good evening, everyone. We are starting our today's session. Uh, we are Team Tesla. We are sorry for the inconvenience. We are Team Tesla. We are once again here for an exciting event. Before we start our session, let me introduce to our club. We are Team Tesla Club of NIT Patna. Tesla stand for Technical Electrical Society of Learning and Application. In our club, we not only focus on traditional engineering concepts but also on the latest cutting edge technologies such as web development, Android development, Web3, blockchain, drones, robotics, IoTs. Our club was established to elevate the potential of future engineers in core as well as IT field. Now, meet our professor in charge. He is Dr. Amitesh Kumar, a very wonderful professor and a mentor guiding us throughout our event. You can connect him on LinkedIn for any guidance. Today, we will be focusing on topic BMS. BMS stand for Battery Management System. This will be a wonderful session. Now, my fellow teammates will start the session.
So, as we all know that India is experiencing a transformative shift towards the electric mobility. Now, we should wonder why. The reason is very simple. We have to find an alternative of the conventional ICE, that is internal combustion engine. And for that reason, we shift to electric mobility. And the reason is that fossil fuels are very limited in nature and we have to limit the carbon consumption too. So, central to this transition is the role of battery management system in ensuring the efficiency, safety, and longevity of the electric vehicle batteries. Now, we have a brief introduction about BMS. BMS refers to the management scheme that not only monitors, controls, or optimizes the individual performance of the battery but also individual cell. BMS can control the disconnection of modules from system in the event of abnormal conditions. For example, if there is a heat between cells and which can cause fire hazards, it is used to improve battery performance with proper safety measures within the system. A BMS holds features such as battery balancing, state estimation, and modeling, which are the key points to optimize and protect the battery in EVs. Now, I have attached a block diagram of typical battery management system. For battery management system, as it is battery, so electric control will be there, and to control that electrical control, user interface is also there. Now, in battery management system, there are battery state for state determination, and for data execution we have to ensure that current voltage temperature and other parameters of the cells consisting in battery should be optimized for safety protection of the consumer. And to ensure all this we have to ensure proper communication between us. And as battery is there, so thermal problem must be there because heating problems are there. So thermal management system plays a very key role in BMS. Now the question arises, why do we need it? Where battery management system is used? Most widely battery management system is used in EVs, in electric vehicles. Not only is a battery management system is important in indicating the health of the battery, but it also functions to protect the battery while it is in the operation mode. Means when the electric vehicle is running, battery management system plays very important role. Each battery cell and chemistry has its own voltage, temperature, and current range within which it can safely operate. When a cell drops below or exceeds these ranges, it can be detected and controlled by BMS. For instance, lithium is very high reactive element which can react with high temperature existence or other chemical. Thus, BMS should monitor each parameters of lithium cell to ensure that it remains in operating within predefined limits. Now, individual cells within the battery pack do not operate equally. For example, a battery has many cells, so each cell do not contribute equally, but different different capacity of cells are utilized. One cell may be weaker or stronger than the other, charging or discharging faster than others within the chain. The BMS also helps to monitor and control the charge demanded from each cell in the chain, ensuring that SOC remains evenly distributed. Now, a small introduction about density in BMS. For example, we have seen that in upcoming years, as advancement is going on, BMS means energy of the cell density is increasing by day. And if a small question arises, what electrical density actually means? Electrical density is basically kilowatt hour upon kg. It's simply energy per unit kg, means the energy which is delivered by a unit of battery. We can say that if density is increasing, means the denominator part, which is kg, is decreasing, means weight is decreasing day by day, and that's what we wanted. In electric vehicle, BMS plays a very important role, and for that the weight of the battery should not be very high as it impacts the vehicle. So, but we are compacting the battery. But while compacting, we must be aware that the compact compactability affects the structure of BMS. Means there are heating problems which can cause fire hazards. Now, some of the functions or components of BMS are listed below. The BMS can perform several functions which are included: state of charge, normally abbreviated as SOC. It is used to determine the amount of charge remaining in the battery, which is very important. A consumer who is riding on e-vehicle must be aware of the battery consumption of his vehicle. Cell balancing equalizes the charge level of individual cells within the battery to prevent overcharging or undercharging. As said earlier, overcharging is very dangerous because it may cause heating hazards, over voltage or under voltage protection. So, as mentioned earlier, overcharging can cause heating problems. So there must be protections also. There are two main protections are there: over under voltage and over short circuit current protection. Short circuit and over current protection are, it prevents excessive current flow, which can damage the battery or can short circuit and cause fire. Now, temperature monitoring. How we will come to know from outside that our vehicle is can caught fire or our battery can short? It can be helped to sensor which detect temperature, monitors the temperature of the battery to prevent overheating, which can damage the battery or cause other safety hazards. Now, to summarize the function, a flowchart is shown of battery management system. Monitoring is a key purpose of battery management system, but we have to keep in mind that protection, communication, and data management is also key role. Data acquisition, as said earlier, current, voltage, and temperature should be kept in mind while the consumer is riding the vehicle by the producer. Charging and discharging management is also key role. Now we come to components of battery management system.
As mentioned, BMS is essential to regulate and protect the battery. There are various components in this BMS. These majorly are battery cell monitors, cut-off FETs, monitoring of temperature, cell voltage balance, BMS algorithms, and real-time clock RRTC, which together works to allow the BMS to optimize the battery performance. Now, in this attachment, we have seen the battery management systems diagram in which we have a battery pack, BMS, and a CAN bus controller. In battery pack, there are numerous cells from cell 1 to cell n, which would discharge and give signals to the BMS in the form of voltage, current, and temperature. These voltage and current and temperature is processed by the BMS to estimate various parameters such as state charge, state of health, and thermal management, which also, this BMS gives the signal to the CAN bus controller, and thus the CAN bus controller further processes these parameters and give the required signal to the circuit, which we could get a desired output from. Now moving on to the battery cell monitors. Now we are going to discuss in details of these various components. Now battery cell monitor system. It is a high-speed system that offers a low measurements, and to easily determine the each and every cell's voltage level, the reference voltage level is set. So, when the voltage of the first cell reaches the voltage limit, the charging automatically trips. It indicates that the battery charging limit has been reached. If the battery pack has a lesser charge than the average cell, then the least charged cell will reach the limit first, and the rest of the cells will be left partially charged. Now moving on to the cut of FETs. Now first we're going to know what is FETs. FETs is an electronic active device which is also a voltage control device and is unipolar in nature. It means that FETs are the field effect transistors. These cutoff FETs are connected to low and high side of the battery pack. It basically is used for connection and isolation between load and charger of the battery pack. The behavior prediction is done through voltage, current measurements, and real-time detection security. The NMOS FETs activation is needed for enabling high-side connection and requires a charge pump driver. A reference for the solid grounding is set using a high-side driver for the rest of the circuitry. The ground connection of the battery pack floats using low-side cutoff FETs. This can affect the IC performance, making it more sensitive to insinuate noise measurement. Now moving on to the monitoring of temperature. While working, the battery is constantly used to deliver current and voltages required for various operation of the device or circuit to give us the desired output. This leads to a rise in temperature of circuits cause damage. Now, to prevent these, we need temperature sensors or temperature sensitive devices for the detection of the rise or a fall in the temperature, because both of these are hazardous to the battery's long life. Now, temperature sensor monitors the energy stored system or cell grouping for compact portable applications. The circuit temperature is monitored by internal ADC voltage power thermistor. Employing the internal voltage reference helps reduce the temperature inaccuracies and improves overall measurement systems. Now moving to the cell voltage balancing. Cell voltage balancing determines the health of the battery pack and monitors to prolong the battery life. The operating voltage ranges from 2.5 volts to 4.2 volts in a lithium ion battery. Battery life is significantly affected by performing battery operations beyond the voltage range. This reduces the life of a cell, which may even make it unfit for use. Now, health affected is not by only these measurements. There are also the rise in temperature, which could lead to the damage of the battery pack. Overloading, corrosion in the instrument or device, or defect in manufacturing, or improper maintenance could also lead to decrease in the longevity of the battery life. Connecting the battery pack in parallel increases the overall drive current, whereas series connection adds the overall voltage. Now we see the BMS algorithms. BMS need a microcontroller to collect, organize, and access information from sensing circuitry to make the most effective decisions quickly in real time. The most popularly used is the Renesas ISL 94203, and basically it is a standalone digital solution embedded in a single chip with programmable capabilities, which means it is a chip which contains programs having solutions that can be executed for various situations. The memory space and microcontroller for battery management system clock cycles can be cleared using these standalone solutions. Now, real-time clock. Real-time clock or RTC in BMS accurately it timekeeping and time stamping. It also helps in tracking battery usage patterns, scheming maintenance, and managing operations. It basically is related to time related function operation, and it allows the user to know the battery pack's behavior before any alarming event. The real-time clock acts as a block box system for time stamping and memory storage. The RTC ensures the time-related functions operate even when the main system is powered down, providing continuity in data logging and event tracking. Now, working of the BMS. BMS tracks status of each cell by determining the SOC and SOH. SOC, state of charge, and SOH is state of health, helps estimate the current needed for safe charge and discharge without harming the battery. BMS continuously tracks charge and discharge activities for battery pack and monitors cell voltage. This data is useful for cell balancing. The current limits act as a cutoff and prevent the battery from overcharging. This safeguards the cell voltages of the battery pack from high or low fluctuation, which immunes the battery life. Now, BMS constantly tracks the charge and discharge activities for the battery pack and monitors the cell voltages. This data is useful in deciding if the battery is drained, sustaining passive cell balancing. The CAN or Controller Area Network bus is a reliable unit for internal communications, driving most of the messaging protocols. The IEM or Intelligent Electric Meter estimates the state parameters of the battery pack like total current and battery pack voltage. It transfers the information to the central monitoring unit or sub-control unit. The sub-control unit checks the temperature and voltage and sends data to the CAN bus. The BCU or battery control unit obtains these signals from the CAN bus and responds by transmitting control signals to the battery pack for managing and modeling. This is the layout of battery management system. It contains a current limiter, a current sensor, contactor, load charges, BMS powers, and main controller cell interferences also. This the current limiter helps to limit the current. The load charge has a and the main controllers send signals to the required circuitry to get the desired output.
Now we will talk about the types of BMS. Battery management systems range from simple to complex and can embrace a wide range of different technology. However, these systems can be categorized based upon their topology, which relates to how they are installed and operate upon the cells or modules across the battery pack. There are mainly four types of battery management system. They may be centralized BMS architecture, modular BMS topology, primary subordinate BMS, distributed BMS architecture. Now we will talk about centralized BMS architecture. What is it? It is and what are its advantages and disadvantages. First of all, we will introduce the construction. It has one central BMS in the battery pack assembly. All the battery packages are connected to the central battery management system directly. Now we will talk about the advantages. The centralized battery management system has some advantages. It is more compact and it tends to be the most economical since there is only one battery management system. However, there are disadvantages of a centralized battery management system. Since all the batteries are connected to the battery management system directly, the BMS needs a lot of ports to connect with all the battery packages. This translates to lots of wires, cabling, connectors, etc. in large battery packs, which complicates both troubleshooting and maintenance. Now we will talk about the another type of BMS, that is modular BMS topology. Similar to centralized implementation, the BMS is divided into several duplicated modules, each with a dedicated bundle of wires and connections to an adjacent assigned portion of a battery stack. In some cases, these BMS submodules may reside under a primary BMS module, oversight whose function is to monitor the status of submodules and communicate with the peripheral equipment. Due to duplicated modularity, troubleshooting and maintenance is easier and extension to larger battery pack is straightforward. Now, the downside is overall costs are slightly higher and there may be duplicated unused functionality depending on the application. Now, we will talk about the primary subordinate BMS. Conceptually similar to the modular topology, however, in this case, the slaves are more restricted to just relaying measurement information and the master is dedicated to computation and control as well as external communication. Therefore, while the modular types, the costs may be lower since the functionality of the slaves tends to be simpler with likely less overhead and fewer unused features. Distributed BMS architecture. Consequently, each BMS is more self-contained and handles computations and communications as required. However, despite this apparent simplicity, this integrated form does make troubleshooting and maintenance potentially problematic as it resides deep inside a cell module assembly. Costs also tend to be higher as there are more BMS in the overall battery pack structure. It is considerably different from the other topologies where the electronic hardware and software are encapsulated in the modules that interface to the cells via bundles of attached wiring. A distributed BMS incorporates all the electronic hardware on a control board placed directly on the cell or module that is being monitored. This elevates the bulk of the cabling to a few sensor wires and communication wires between adjacent BMS modules. Now we will talk about the advantages of BMS. A battery management system has the following advantages: enhance the lifespan of the battery cells in electric vehicles, measures and controls the cell's voltage, providing stability and reliability, ensures the safety of the battery pack, especially large format lithium ion batteries, optimizes the performance of the electric car battery, improves safety by reducing the need for physical contact with the battery bank, estimates the range the vehicle can travel and helps improve the battery pack's overall life cycle, provides diagnostics, data collection, and external communication, reduces cost and warranty. Now we will talk about the other advantages of BMS in electric vehicles. BMS has several significant advantages for electric vehicles. These benefits include performance optimization. BMS helps derive the maximum performance of the battery packs to extend the driving range and battery longevity through automated mechanisms to resolve anomalies and malfunctions pertaining to the battery. Safety and reliability. BMS has complete monitoring and safety mechanisms for overcharging, draining, and temperature abnormalities. This ensures the safety and durability of the battery, thus minimizing accidents or failures for electric vehicle buyers. Real-time data and diagnostics. Battery management system observes batteries in real time, records data for logs on battery health, and identifies malfunctions. This helps OEMs schedule proactive maintenance to rectify issues and significantly enhance customer satisfaction. Now, optimized charging. BMS manages the charging process to ensure that each cell reaches its optimal state of charge. This helps avoid overcharging, a factor that can significantly impact the battery's lifespan. BMS also implement fast charging protocols while considering the battery's health and safety. Range optimization. By accurately monitoring the state of charge and health of battery, BMS helps optimize the use of available energy. This optimization contributes to maximizing the driving range of the electric vehicle on a single charge. Thermal management. BMS monitors and manages the temperature of the battery pack. It can activate cooling or heating system as needed to keep the battery within the optimal temperature range. This is crucial for maintaining battery efficiency and preventing thermal related issues. Regenerative braking control. Many electric vehicles utilize regenerative braking systems to recover energy during braking. BMS plays a role in managing the regenerative braking process, ensuring that the battery can accept the regenerated energy safely and efficiently. Data logging and analysis. BMS records and stores data related to batteries' performance over time. This data can be valuable for diagnostics, maintenance planning, and optimizing further battery designs. Complements with standards. BMS helps electric vehicles complying with safety and performance standards and regulations. This is crucial for the acceptance and approval of electric vehicles in the market and by regulatory bodies. Now, in summary, a battery management system is a critical component in electric vehicles, providing benefits such as enhanced safety, extended battery life, optimized performance, and compliance with industry standards. The use of BMS technology contributes significantly to overall efficiency and reliability of the electric vehicles. Now, this is the pictorial representation of the advantages of BMS in electric vehicles. As here we can see that uh, it improves the vehicle range and performance, battery cell balancing, self, safe operation, battery ages, thermal management, and charging.
Now we discuss about the consequence if we don't use appropriate BMS. A battery management system is a critical component in managing and protecting rechargeable batteries. If you don't use an appropriate BMS or neglect its importance, several types of consequence can arise. Number one, reduced battery life. Overcharging or over discharging of batteries can significantly reduce their lifespan. A battery management system helps prevent this condition by managing the charging and discharging process within safe limits. Number two, safety hazards. Lithium ion batteries commonly used in many applications can be prone to overheating and in extreme cases can lead to thermal runaway or fires. A battery management system includes safety features to monitor and control temperature, voltage, and current, reducing the risk of accident. Number three, performance degradation. Without proper management, the performance of the battery can degrade over time. This can result in a decrease in capacity, efficiency, and overall functionality. Number four, unreliable operation. An inadequate battery management system may lead to unreliable operation of electronic device or system that rely on batteries. This can be particularly problematic in critical applications such as medical devices or electrical vehicles. Number 5, imbalanced cells. In a battery pack with multiple cells, each cell may have slightly different characteristics. If not managed properly, these differences can lead to imbalance in voltage and capacity among cells. A battery management system helps balance the cell during charging and discharging to maintain uniform performance. Number 6, warranty issues. Neglecting to use an appropriate battery management system might void warranties provided by battery manufacturer. Many batteries come with specific requirements for proper management to ensure their longevity and safety. Number 7, environment impact. Improperly managed batteries can have a negative impact on the environment. This includes both the potential for hazardous material to leak into the environment and the need for more frequent disposal of batteries due to reduced lifespan. Number 8, regularity compliance issues. In some industries, there are regulation and standard governing the use of batteries, especially in applications like EVs, electrical vehicles, and energy storage system. Failure to comply with this regulation can lead to legal consequence and liabilities. Number 9, financial cost. In the long term, the cost associated with premature battery failure, safety incidents, and system downtime can be sustainable. Investing in an inappropriate BMS can be cost-effective way to mitigate this risk. In summary, using an appropriate battery management system is crucial to ensure the safe, efficient, and reliable operation of battery powered device, the system. This helps maximize battery life, prevent safety hazards, and comply with industry standard and regulation. Neglecting the importance of BMS can result in various negative consequences, both in terms of performance and safety. Now we discuss about the challenges of BMS in India. Here are some of the challenges that are associated with battery management system in India. Number one, infrastructure and charging network. The development of electrical vehicle in India is closely tied to the establishment of adequate charging infrastructure. The lack of widespread and efficient charging network is a challenge for the adoption of electrical vehicles, and this indirectly affects the role and requirement of battery management system. Number two, cost consideration. The cost of electrical vehicle, including the cost of battery management system, is a significant factor influencing adoption. Battery management system technology need to be cost effective to make electrical vehicle more affordable for the average consumer. Number three, supply chain and manufacturing. The development of robust supply chain of battery management component and manufacturing capabilities is crucial. Dependence on imports and supply chain disrupts can hinder the growth of battery management system industry in India. Number four, technical expertise. Developing and maintenance the technical expertise required for the design, development, and implementation of advanced BMS can be challenged. This includes both research and development capabilities as well as skilled labor, manufacturing, and maintenance. Number five, battery recycling infrastructure. The disposal and recycling of batteries, including those used in EVs, pose environmental challenges. Establishing proper recycling facilities and processes is essential for the sustainable growth of the battery management system industry. Number six, regulatory framework. A clear and supportive regulatory framework is crucial for the growth of the electrical vehicle and battery management industries. Regulation related to the safety standard, interoperability, and environmental concern need to be well defined and implemented. Number seven, consumer awareness. Increasing awareness and educating consumer about the benefits of battery management system, technology, and electrical vehicle is important. A lack of awareness can contribute to escapism and slow adoption rates. Number 8, range anxiety. Concern about the driving range of electrical vehicle, often referred to as range anxiety, can be deterrent for potential EV buyer. Developing battery management system technology that optimizes battery usage and increases the driving range is important for the addressing of concern. Number 9, interoperability standards. The establishment of interoperability standards of battery management system across different manufacturers is essential. Standardization facilitates compatibility, reduces cost, and encourages innovation. Number 10, government incentives and policies. The absence of consistent and supportive government incentives and policies for electrical vehicle and associated technology, including battery management system, can hinder market growth. The application will be introduced by my fellow mates.
Of battery management system. Battery management system play a crucial role in various applications, ensuring the optimal performance, safety, and longevity of batteries. Here are some key applications of battery management system. The first one is electrical vehicles. Battery management system is essential in electric vehicles to monitor and manage the state of charge, state of health, and temperature of battery pack. The second one is renewable energy system. Battery management system is used in energy storage system that store electricity generated from renewable sources such as solar panel, or wind turbine. It helps manage the charging and discharging cycle, ensure grid stability, and maximizes the utilization of renewable energy. Now, the third one is consumer electronics. Portable electronic devices such as laptops, smartphones, and tablets utilize the battery management system to monitor and control the charging and discharging of batteries. Battery management system helps prevent overcharging, over discharging, and overheating, enhancing the safety and lifespan of the batteries. The fourth one is uninterruptible power supplies. Battery management system is employed in UPS system to manage the batteries that provide the backup power during outage. It monitors battery health, ensures a reliable power source supply, and prevents issues like deep discharging or overcharging. The fifth one is telecommunications. Battery management system is used in backup power system for telecommunications infrastructure. It helps ensure a continuous and reliable power supply, preventing downtime during power outages. Sixth one is medical devices. Medical equipment, especially those relying on battery power, use battery management system to monitor and control battery parameters. This is critical for devices like portable medical monitors, infusion pumps, and other battery powered medical instruments. Seventh one is aerospace and aviations. Battery management system is employed in aerospace applications including satellites, unmanned aerial vehicles, and electric aircraft. It helps manage the energy storage systems and ensure the safe and efficient operation of these vehicles. The next one is grid energy storage. Battery management system is integral to large scale energy storage system connected to electrical grid. It helps regulate the flow of energy, support grid stability, and facilitate the integration of renewable energy sources. Next one is marine and electric boats. Electric boat and marine vessels use battery management system to manage the energy stored in their batteries. Battery management system helps optimize performance, control charging and discharging, and ensure the safety of battery system. The next one is material handling equipment. Electric forklifts and other material handling equipment often use battery management system to manage their battery packs. This ensures efficient operation, longer battery life, and safety during charging and discharging. In essence, wherever rechargeable batteries are used, battery management systems play a critical role in maintaining the health and performance of the battery system, ensuring safety and optimizing energy usage. As we can see in this figure, in industrial field, management applications include cleaning machines, forklifts, crane and lifts, accessory drives, robots, industrial drones, and trains. In automotive fields, its application included bus, trucks, sports cars, passenger cars, motorbikes, utility vehicles. In next one, marine field. In marine field, its applications include submarine, laser, passenger boats, UAV. In light electric vehicles field, its applications includes scooters, three-wheelers, golf cars, park and garden. Energy fields, its applications include PV time shifts, peak savings, grid support. Now we talk about issues of battery management system. When the number of wires and connectors between cell monitors increases, there are two challenges. One is layout changes such as split packs increase wire length, cost and weight. The other is an increase in failures such as wire break and poor connector. Battery as we can see in this figure, the issues is shown as the first issue is layout changes such as splitting a pack can result in wire length, stretch, cost and weight increases, and the next issue shown in this figure as more failures such as wire breakage and poor connector contacts. Battery management system issue can vary, but some common issue includes cell imbalance. Over time, individual cell is a battery pack can drift in terms of a state of charge. Battery management system should balance these cells to ensure optimal performance and lifespan. The next one is overcharging and over discharging. If the battery management system fails to monitor and control the charging and discharging process, it can lead to overcharging, which can damage cells, or over discharging, which can reduce battery lifespan. The third one is temperature management. Battery can be sensitive to temperature. Battery management system must monitor and regulate temperature to prevent overheating The next one is communications error. Battery management system relies on communication between its components. Issues in communications can lead to inaccurate reading, improper control, and overall system failure. The fifth one is faulty sensor. If sensor providing data to the battery management system are faulty, or it can result in incorrect monitoring and control decisions. The next one is software bugs. Like any complex system, can uh, battery management systems can have bugs or glitches that may lead to improper functioning. The next one is insufficient cooling. In high demand situation, inadequate cooling mechanism can lead to increased temperature, negativity, impacting battery performance and lifespan. The next one is power balancing issue, ensuring that power is distributed evenly among cell in crucial. Failures in power balancing can result in uneven wear and tear on cells. The next one is limited state of health monitoring. Some battery management system may not effectively monitor the state of health of the battery, making it challenges to predict and prevent degradations over time. The last one is safety concerns. A battery management system should ensure the safety of the battery pack of preventing conditions that could lead to thermal runaway short circuits or other hazardous situations. Addressing these issues require a comprehensive approach including regular maintenance, timely software updates. Now we are talking about battery trends. There are two major trends in battery technology today. The first is to increase the capacity to extend the driving range. The other is increasing pack voltage for high efficiency. From the viewpoint of the number of cells, increasing the capacity increases the number of cells in parallel and increases the voltage, increases the number of cells in series. Leading is battery packs are being split into banks that are connected in series for charging and in parallel driving optimizing the performance but still increasing the cell count. Based on these trends, the number of cells in the battery pack will continue to increase. As we can see in this figure, increasing capacity to extend driving range in terms of cell potential as shown, higher capacity means more cell in parallel, increasing voltage for high efficiency. In terms of cell connections, here shown in this figure, higher voltage increase the number of cells in series.
Now, after understanding the basic theory about BMS, now we should know what is the scenario of BMS in India. BMS stands for Battery Management System, as I told you earlier also. They are very crucial for efficient and safe operation of the batteries, particularly in the context of electric vehicles and renewable energy storage. And the question again arises, why renewable sources of energy? Because we cannot rely more on fossil fuels, which are limited in our world and which can degrade any time after period of time. In India, there are several key players and intensive which are discussed below in the BMS sector. First one is Aligned India, which was established in about 2012. Aligned India is a leading manufacturer, importer and exporter and trader of the battery management system. They have a specialization in BMS for LFP and lithium ion NMC batteries. Their product ranges from BMS boards, battery enclosures, cell holders, and other materials of batteries. Now we come to ARAI, which abbreviation is Automotive Research Association of India. ARAI has developed an indigenous and India specific cost effective technology, which is very important. Cost efficient is the key parameter in which consumers look after. This intelligent energy management system ARAI EMI4 is a complete software and hardware platform comprising of advanced algorithms for energy management and automotive complement hardware to interface with the energy source. Now the third one, which is the ongoing standard on which working is still going on, is BIS standard. NITI Aayog. BIS stands for Bureau of India Standards under the guidance of NITI Aayog, which is still working on standardizing the form factor of the battery pack, interoperable connection system, communication between BMS and EVs, which is essential. There should be a communication between BMS and EVs and the charging station, and for network management too. The all above incentives which I mentioned are reflect to the growing importance of the BMS in Indian transport system towards electric mobility and renewable energy. As the demand of electric vehicles and renewable energy storage system increases, the role of BMS is ensuring the safely, efficiently, and the longevity of the battery system will become even more critical. Now we will conclude our battery management system session.
So, in conclusion, battery management systems are playing a crucial role in shaping. Uh, a battery management system is like a smart guardian for batteries. It monitors and manages things like violet, like voltage, temperature, and ensures each part of the battery is working well. Think of it as a battery's personal caretaker, making sure it stays healthy and perform at its best. So in this session, we came to know about block diagram of typical battery management system, need or importance of BMS in EVs, its functionality and components, algorithm involved, detailed working and layout of BMS, types of BMS, advantages of BMS, and also the consequences if we don't use the appropriate BMS. We also got to know about the challenges involved in BMS in perspective of India, various applications of BMS, and at last we discussed battery trend. So basically the we also got to know about the key components of battery management system. Some of them are like first optimizing performance, second enhancing safety, third prolonging battery lifespan, then integration with charging infrastructure, economic viability and affordability, government support and regulations, challenges and future outlook. And in the last, moving towards the end of the today's session, we thank you all, our loved. We thank you all loved our. We thank you all that you loved our today's session. Thank you for being a wonderful audience.
Now, there was a small question that why electromagnetic way of charging vehicle is not being used in India. A simple reason may be come into mind that if you go for electromagnetic vehicle charging, such as wireless charging, it may influence other factors such as infrastructure cost, means cost will be high of the battery, and that not we want as a consumer, because as a consumer everyone wants cost effective battery, or we can say electric vehicle. As I said earlier also that BMS is used in electric vehicle, so if we will use electromagnetic vehicle charging, the cost will go high and it will lead to hike in electric vehicle price. Any other doubts you can post in the comment section of YouTube. We will try to deal it afterwards. We have done with today's session. You can leave and don't forget to like and subscribe the channel.
Do follow us on our official Instagram, LinkedIn, Twitter, and